In any physical environment, decisions depend on understanding how people move, where demand concentrates, when peaks happen, and where friction appears. Without that visibility, teams either over resource or react too late. Hi, my name is Waldir Nunez, and in this presentation, I'll share an overview of my industry placement in footfall analytics and the project I developed alongside it. I'll start with the problem and what footfall analytics is, then a quick overview of footfall cam and my placement tasks. After that, I'll walk through the project motivation, design, and implementation, and close with challenges and key learnings. The recurring asks are, do we need more staff? Which locations outperform and why? If campaigns increase visits or just pass by traffic, and where bottlenecks like queues and congestion actually happen. These questions usually come from operations and site teams, planning, staffing, and responding to congestion, and from leadership teams comparing performance across locations. Now, they matter because the impact is immediate: labor costs, customer experience, and missed demand. Now, what is footfall analytics? Footfall analytics is the measurement and analysis of visitor traffic in physical environments. It's used to quantify customer volumes, identify temporal demand patterns, measure dwell behavior, and compare performance across locations. Have you ever walked into a mall and wondered how they actually know which entrances get busy first, or when queues are about to form, or whether a campaign truly brought the right kind of traffic? Now that's exactly what FootfallCam does. FootfallCam is a visitor analytics company that helps organizations measure, understand, and optimize how people move through physical spaces, and this is done accurately, at scale, and in real time. Now, think of it like giving a building a set of eyes and a brain. Not just counting people, but turning foot traffic into clear, actionable insights. One of the core strengths is 3D people counter technology. This enables sites to track footfall by entrance, peak hours, and flow patterns, so teams can staff smarter, reduce congestion, and improve the visitor experience. They also offer heat mapping and zone analytics, showing where visitors spend time, where engagement concentrates, and where friction happens, helping retailers and landlords, for example, make better decisions on layout, merchandising, and leasing. And they don't just work with retailers, they work with a wide range of industries such as shopping malls, such as, for example, public spaces, telecom, etc., etc. At a high level, the flagship products are Pro 2, the Centroid, and the Beam Analytics Manager, as I mentioned. Common outputs include footfall in and out, occupancy and congestion signals, dwell time as a behavioral proxy, pass by and turning rate, demographics, which is quite important, and queues and zone engagement analytics. My placement role as a data solutions consultant focuses on discovery and alignment, translating stakeholder questions into measurable requirements, KPIs, granularity, filters, and cadence. It also involves KPI definition and interpretation, helping clarify what metrics mean and what they don't. And finally, it includes integration and data pipeline thinking and POC support, defining what success looks like and what counts as signal versus noise. As I mentioned, FootfallCam manufactures both the hardware and the software, so the company controls the full chain, from data capture to insights. And by being part of the team during this placement, I've had the chance to see that end-to-end process firsthand, how raw traffic signals are collected in real environments, how they are validated and structured, and how they're ultimately turned into reporting that operational and commercial teams can actually use. And that experience is precisely what shaped my project choice. Now, for my project, I decided to build my own analytics dashboard designed to effectively showcase key traffic measures, things like overall footfall trends, temporal patterns, comparisons across time periods, and performance difference across locations, in a way that is clear, decision-oriented, and easy to interpret. It's also important to clarify something from the start. This project does not use any information, data materials from FootfallCam or its products. The dashboard and the underlying work are strictly academic. They are developed independently using a separate dataset and my own design decisions. Now that said, the outcome is practical. It was built to mirror the kind of real-world questions teams ask in visitor analytics, and it was implemented successfully as a working end-to-end artifact, from data modeling to KPI definition to final visual storytelling. So with that context, I will now walk you through what I built, how it's structured, and the insights it's designed to deliver. The main objective of this project is to produce an interactive dashboard prototype that supports retail performance assessment using footfall style data. This prototype is aiming to answer three main questions, and those are: number one, what is happening overall? For this, we're going to use executive monitoring of key KPIs, which we will describe a bit later on the project. Number two, when does demand occur? Peak hours, weekday, weekend patterns, and all of those kind of metrics, for example. And number three, where are the differences? We're going to benchmark across stores and regions to see and to note if there are any difference between them. The motivation behind this project is to demonstrate a full workflow in footfall analytics by translating stakeholder-style questions into a decision-ready dashboard. Because real client datasets aren't available for academic use due to privacy and compliance, I created a synthetic dataset designed to mirror realistic store, zone, and time-level patterns. So KPI logic and drill-down behavior can be validated end-to-end. Now, this artifact was developed using Python in VS Code to generate a reproducible synthetic dataset and export later on as CSV format. After that, Power BI is then used to ingest the dataset, build the semantic model, implement DAX measures, design report pages as well, and configure interactive behaviors like filters, drill-through, and cross-highlighting. In order to keep the project fully self-contained, I built a synthetic dataset so nothing in the dashboard comes from confidential company or client data. But I didn't want the data to feel random. I designed the generator to behave like real retail traffic. You see intraday peaks, differences between weekdays and weekends, clear differences across stores, seasonality, and the occasional promotional spike. Now, that way, the dashboard can be assessed properly on how interpretable it is, how well the interactions work, and whether it actually supports decision making. And to keep everything neutral, the stores are labeled from 1 to 12 with no real brand names. Now, the dashboard is implemented as a 3-page Power BI report to separate monitoring, diagnostics, and benchmarking, and reducing cognitive load as well. Page 1 is going to be an overview for a KPI snapshot and variance. Page 2 is time analysis for example, intraday patterns, weekday, weekend differences. And page 3 is a store comparison for benchmarking, including a day-by-hour matrix view. Now I would like to discuss the different KPIs used for this project. The total footfall measures overall traffic. Unique visitor is a proxy for, of course, distinct visitors. Now, the average draw adds behavioral context, which is important in these sort of scenarios. Transactions are, of course, a commercial outcome proxy, while conversion rate links transactions to footfall. And finally, footfall per staff provides an operational workload and coverage indicator. So what is the rationale for simulation? Expected hourly demand mu is computed as mu equals 80 times F times base hour times the day of week multiplier times seasonality times promo. Footfall is sampled around mu with control noise at 18% of mu and clip at 0. Unique visitors is generated as 70 to 95% of footfall. The average dwell minutes increases around peak periods on weekends, and it is clipped between 5 and 60 minutes. The transactions are generated using a bounded conversion propensity of 2 to 18% with multiplicative variation. For the full implementation details, you can consult the report. Now, this is the overview page. The goal is rapid triage, headline KPIs, a trend view to spot direction and variance, and a store comparison visual. This one helps users quickly identify where attention is needed before drilling deeper. Now, the time analysis page helps users identify peak and low traffic windows, assess weekday versus weekend patterns, and distinguish short-term volatility from sustained change, supporting decisions around staffing, for example, opening hours, and campaign timing. Finally, the store comparison enables benchmarking across sites and zones using consistent definition. The table and the matrix views make it easy to surface underperformance, for example, prioritize investigations, and then use drill down to form hypotheses for follow-up analysis. Overall, the dashboard supports core decision workflows by translating footfall signals into operationally relevant views. Overview enables fast triage, time analysis explain when demand occurs, for example, and whether changes are meaningful, and store comparisons standardizes benchmarking so differences are easier to interpret and improvements can be tracked over time. My key takeaways are that industry analytics wins on clarity and governance, not fancy models. That's why the dashboard is designed to be simple, explainable, and reproducible. Now, the next step in a real setting is to validate on representative deployment data and extend KPIs based on decision impact. As part of my project, one of the key challenges was building a 3-page dashboard that was analytical and decision ready, not just descriptive. I started by grounding the design in relevant literature and established visual analytics principles, so the structure and metrics were defensible and not just based on intuition. Then the practical challenges kicked in, translating broad business questions into measurable KPIs with explicit assumptions and a consistent uniform analysis, hour, day, store, for example. After that, it became a data quality and validation task, profiling distributions, checking missing periods and outliers, and making sure calculations behave consistently across filters and locations. Now, finally, I designed it for interpretability, so adding context like baselines, day-of-week effects, and time window comparisons to reduce misleading conclusions was important. Overall, the challenge wasn't just building visuals. It was applying data science thinking so the insights were accurate, explainable, and trustworthy. As a data solutions consultant, one of the biggest challenges is that everyone shows up with a different idea of what success even means. Operations, they want something actionable they can use next week. IT cares about feasibility, security, and whether it will break their stack. And leadership, they want clean KPIs and a story they can confidently take upstairs. So before we even build anything, our first job is usually alignment, getting everyone to agree on one shared definition of success. What we're solving, how we'll measure it, and what good looks like. Another challenge is that the initial request is almost always too broad. People say, we need prediction, or we want automation, can you add AI? But that's not a scope, that's just a wish, right? And then there's trust. Trust is everything in this role. You earn it by being super clear about what the KPIs can and cannot claim, and by keeping the narrative consistent, especially when the results look weird. If the numbers look surprisingly good or surprisingly bad, people start jumping to conclusions. And that's when you step in, explaining what's happening and keep everyone grounded. Over the course of this placement, my first big learning was simply how footfall analytics works in the real world. It's not just counting people. It's taking movement data and turning it into operational signals team can actually use. For example, traffic trends, peak periods, dwell patterns, and performance comparisons across, say, entrances, zone, areas, etc. And one thing that surprised me a lot was actually where the real value comes from. Now, most of the time, it's not just fancy AI, right? It's getting the fundamentals right, trustworthy measurement and consistent interpretation. If the basics are off, every insight becomes questionable. It doesn't really matter how advanced the modeling is. I have worked with several projects during this placement, and the ones that work best day to day had 3 things nailed. Now, the first one is KPI governance. Clear definitions of what we're measuring, the assumptions behind it, and the data boundaries. The second is the problem framing, taking stakeholder requests and translating them into measurable questions with success criteria that everyone agrees on. And third, of course, communication, presenting results honestly, including limitations, what the metrics can support, and what they simply can't claim. So my final takeaway is that in operational environments, the analytics that win aren't the most complex. They are the ones that are reliable, explainable, and actionable, because those are the ones that people trust and they actually use. And this is everything for today. Thank you very much for your attention.